This tiny photonic circuit. It's so cool. Free-formed LED blinker. It's modified Joule thief circuit with two coils which are close together and coupled. And this network gives time constant for blinking. There are 4 photodiodes and supercapacitor. To make pulse the Joule thief, it is to use resistor and capacitor to decouple from main power supply, make temporary charge, and then it works with such coils, but it not work with these coils. With 200 microhenry inductors, pulses are quite dim. Waveform we see about 20 milliseconds pulse train. With 1000 microhenry in the base, pulses are very strong, and the pulse length is 10 milliseconds. The working voltage is 0.8 volts when it stops. It doesn't work with equal inductors of 1000 microhenries, 1 millihenry, 10 microfarads, 10 kiloohms works, 50 kiloohms does not work. 47 microfarads, the 50 kiloohms doesn't work. 47 microfarads, 10 kiloohms works nice. 10 kiloohms, 100 microfarads works from 0.6 volts. With 1 kiloohm in series we get basically permanent flashing, or they cannot see individual flashes. Like these coils now are making step down transformer, and then it doesn't work. So what actually matters is the ratio of number of turns. In the base should be more turns than in collector to make step up transformer, and at low voltages matters also polarity of the coil, direction of the windings. On the oscilloscope we see pack of 2 microsecond pulses. 100 microfarads give us 12 millisecond pulses. 47 microfarad capacitor gives about 5 millisecond pulses. 10 microfarad capacitor gives about 1 millisecond. We have such envelope. It is important to choose this resistor, that the Joule thief is not running without capacitor. I put 2 microfarad. Microfarads give about half millisecond pulse. And we have such nice chart. Works with 20 kiloohms and 10 microfarad. Put 50 kiloohm resistors and it will not run from 0.6 volts but need 1.1 volt. Solar rocket produces only 1 volt, so it will not run with 50 kiloohms. 10 kiloohms, 47 microfarads runs nicely from solar, runs nicely also through a Schottky diode. More light gives faster blink rate. The problem is that this circuit blinks only 10 times after disconnecting power. Reason could be power dissipation on this resistor, and other could be that inductors are poorly coupled. Such 2 coils close to each other, they are like a transformer with a gap, and the gap can store magnetic energy, it does not saturate. I prepared a toroidal transformer, 25 turns and 50 turns. And one would expect that if you make 2 times more turns, inductivity will increase 2 times, but no, it increases 4 times, because inductivity is proportional to number of turns squared. So we have 4 millihenry and 1 millihenry. When connected to plus directly, circuit draws a lot of current and the voltage is 0.4 volts, which is very good. And this circuit now doesn't work at all through 10 kiloohm resistor. One explanation is that we have coil which is directly connected to transistor base, and the base voltage is 0.6 volts, so we have a lot of losses going to ground. But in other pulsar circuit there was resistor capacitor in series which limited base current, and there was no such resistor. I could not get this circuit running. When added 1 megaohm in the base and 2 microfarads parallel to it, then we get pulsed operation. And this is circuit like I had before. It works nicely from room light with disconnected solar panel flashes quite many times. Resistor and capacitor in power supply and chain. It is not exhibiting high frequency oscillation, always pulsing. This transformer went into LED flasher 1.5 volt battery, and I used electrolytic capacitor, 2 microfarads and 1 megohm resistor. And I was surprised that in oscillogram it is just a single pulse, not many oscillations. And yeah, electrolytic capacitors are good for low frequencies and not good for high frequencies. Maybe that's the reason. But the pulse is short, looks good. Blinker from solar cell, 1000 microhenries, 1 millihenry. Pulse is about 6 milliseconds. With electrolytic capacitor, pulses look similar, 2 milliseconds. Setup is a 5 volt solar panel. Supercapacitor is a good blinker. And supercapacitor actually it consists of 2 to make voltage 5 volts. Supercapacitor I charge to 3 volts. 100 microhenry get permanent oscillation instead of blinking. The 1 millihenry coils are far away. Then we get high frequency oscillation. If they are close together, then get blinking. Actually now is good magnetic coupling. Magnetic field from one coil is closed by the ferrite of another coil. Blinker coils produce radio signals in wide frequency range. Reception is better with radios having magnetic ferrite antenna.